So I'm Ahmed. I'm the founder of Narrator. And previous to this, I built out WeWork's data team and infrastructure, head of data for WeWork. And then before that, I was an AI engineer at Raytheon. So I'm here to talk about how to answer data questions without making yourself miserable. As you can guess, I spent a lot of my life answering data questions, and sometimes it really sucks. The thing about data questions is that no matter how painful they are, it is a company's competitive advantage, and that's what makes the biggest impact on whether a company can succeed and outdo its competition. So let's start thinking about why is answering a simple question really, really hard. Let's start with a question. How does calling our sales center after visiting our site affect signups? Every data person a stakeholder has come to them and said, why this very specific question? And the data person goes, that'll take me 2 weeks. But the business person always goes, why? Why is this question so hard? Well, your sales data, your call data is actually held in Salesforce. Your site data is held in Segment. And your sign-up data is in your internal database. And even if you're able to bring it all together in your warehouse, you still have to deal with a lot of issues. There's no foreign key that ties these two systems together. There's no way to deal with different user identifiers. You would have to just go to your engineering team and ask them to copy that data in all these different places, and then you deal with other issues. Or try to build attribution models and think about what happens if you have 2 calls, or what happens if you have 2 sessions. And this simple question that seems so obvious ends up taking weeks of work. This question made me hate data. This is why I really hated all data questions. Because people would come to me and go, why is this so hard? Why don't you just divide the number of signups by the people that came to the site and called? And I'm like, oh, well, nuance. And how do we solve these kind of problems? Well, like all of you and myself also, we buy a lot of tools. And we think that tools are going to make this system really simple. But tools tend to add a lot more complexity than they actually end up solving. Let's go through tools. So the first tool is your warehouse. We started with Redshift, and then we ended up buying Snowflake. And we were like, Snowflake's going to be faster. We're going to have way more speed and dynamic compute. Well, it turns out that speed doesn't really matter. If you have 1,000 transformations, it becomes way more complicated, so having the additional seconds of speed didn't help us answer questions. We were too busy dealing with all these layers of transformations. So you buy dependency managers, or you use them. We used Luigi, switched to dbt, then Airflow, and then ended up building our own solution to handle our dependencies. But if you guys ever used dependency managers, these layers and layers and layers makes it really hard to debug and really hard to reason about what's going on with your data. So it turns out that dependencies weren't a solution. They were kind of more like a problem. So we ended up trying to figure out another alternative, and we went through the biggest myth of all, which is that BI tools are more than just plotters. I'm really anti-BI tools. Because I bought all of them. Every one of these things I bought. And you spend a lot of money on BI tools, and you hope that a BI tool will create this world of like self-service and standardized metrics. And I was like, that's what I'm going to get. I just bought Looker. It's going to solve my problems. And it doesn't. All it ends up doing is you end up having to hire a team of 5 or 6 BI engineers to write LookML and maintain these systems for you. And all these layers put layers of complexity between me and the data. And I'm really convinced that if you ever try to debug Looker, they purposely make it impossible. You can never figure out what's happening. Try it. Anyone who's tried it will laugh and be like, fuck. So it's true. So with all these tools, we ended up with a lot of money spent on these tools. We actually spent over $1 million. A lot of time and resources. We had a 45-person data team. And then very little impact. We were really just trying to answer some questions, and we were still struggling really hard. Most of our team was dealing with why 2 dashboards numbers don't match, and how do you debug it and figure out what's going on. How many sales was actually a hard question you would think should be easy. So why is this happening? Well, it turns out that all these tools and all these systems are designed to help you build dashboards, not really answer questions. Questions are fuzzy. Questions are nuanced. And having hundreds of dashboards and trying to find the right dashboard or find the right where statement to filter our data never gives you the answer. That's why most of us are either data people or data analysts or have a data team, because you need someone to go assemble the query to get you the data you need. That's because there's a lot of nuance in there. And no matter how many dashboards you have, it doesn't end up solving it. We had 3,000 dashboards, and it was not helping. So this was really the bane of my existence for a while, until I figured out something really simple. Oh, sorry. Oh, there might be a world where you don't need these hundreds of tables to represent your business. We had 3,000 tables, 700 transformation tables. What if you don't need all that? What if your whole business can actually be simpler? Well, it turns out that your business can be broken into 3 simple things: a customer, doing some activity, and time. That's it. So instead of 1,000 tables, you can only have everything can be just customer, activity, and time. What if we actually took that and started structuring our data to be similar to the way we ask questions, not the way we plot them? What if we rephrase data in that format? Well, we end up with a data structure that's just a single time series table. So instead of hundreds of fact and dimension tables, you can just have one time series table centered around a customer. Most of you guys are a little skeptical. I know. I spent the last 2 years of my life explaining to people and trying to preach this world where you can replace all your layers of complexity with a single time series table, and everyone goes, bullshit. So if you bear with me for a little bit, maybe humor me, maybe I can try to convince you that it can work. And just think about the world if it did work. If a single time series table worked, you wouldn't have 20 or 30 data engineers building tables to answer questions. You wouldn't have hundreds of dependencies and layers. You wouldn't have to look through hundreds of different dashboards to figure out if calls affected your sales. You can actually just ask those questions the way you naturally talk. That gap between the way you ask a question and how data answers it can be really, really small. There's not many layers of translations. So what is an activity stream? It looks kind of like this. This is a view per single customer. Customer comes in, they open an email on October 27th, then they start a session on their website. This is the 3rd session. They view some activities. They maybe purchase a product, they complete an order, and then they receive an email. Simple structure, time, activity, customer, and a couple features on there. What if that's all you needed? It could be this easy. And the way I'll show it to you is kind of by going through some questions. Let's take the most simple question. A question that we get a lot. How many products were purchased today? I could rephrase that question in this framework to be, give me all product purchase activities within the time filter for today. And if we wanted to write a query, it would look like this. We would just say select, give me the table where activity is purchase product and the time filter is today. Simple? Easy case. Let's get harder. Remember that question that we answered in the beginning with the 3 different data sources and the complexity behind how do you relate it? That question about how does calling our sales center after visiting our site affect signups? That can be rephrased using activities to say, give me all visited site activities and include if a customer called us or signed up. And the query is a little bit complicated unless you know SQL, but it's actually really simple. Simplifying the same initial started session cohort, and then you just simply add the sign up and call. And instead of depending on foreign keys to relate the data, you can actually just use time and customer. The same way that if you want to validate the data, you kind of look through it and you go, oh, this happened, then this happened, then this happened. We can just replicate that in SQL. And we can actually get a little bit more complicated. What if we wanted to ask, what is the impact of an email on a purchasing of an item? Traditionally, you would have an email have a link, and then you would click on the link, and it would get a UTM that would tie it to a session, then you would deal with that session, bridging it to a purchase. But you can rephrase that question to kind of be a lot more specific, which is, give me all people who open email activities, and included the customer purchased the product within 2 hours of opening that email before the next email. That means if you have opened 4 emails in a row, and you purchase on the 3rd email, we can tie the 3rd email. It means if you open your email on your phone and go on your computer and purchased, we know that you just opened the email, and that's what we can tie that purchase to. And now you bridge system and create an attribution model, and it's very similar query. Very similar query. Still, it's taking the same open email activity, just putting a time filter for 2 hours, and instead of the other 2 filters, we just said where activities purchase product. The really fascinating thing here is that the query is so consistent. I can literally reuse the same query and combine layers of questions all using the same structure, all being answered by the same table, bridging these systems invisibly. This made me really happy because this allowed me, as a single person, to support 16 different companies using 5 different industries, all using the same time series table. I'm going to pause for a second because this would have taken a 100-people data team to actually answer these questions. But now we can literally reuse these answers and we can just assemble data. When we get a question that's how does content affect purchasing, we can just choose the viewed content activity, purchase activity, and automatically we have a table that represents that concept. And we can, because of the consistency, we can build tools around it to answer the same question, all using the same table. And when you remove all these layers of complexity from the data, you actually end up loving answering questions because you don't have to worry about all these layers. You can do what you and all of us really enjoy doing, which is making an impact through data by asking the best question and answering that instantly. And now, all the things that used to bother me no longer there. I don't have to worry about 2 dashboards not matching because all the numbers match. There's only one table. Everything will always match. The next thing is, without having to worry about all these tables and how they relate, modeling these activities becomes trivial. You can have a simple query, 25 lines, on top of your warehouse to structure your data into this activity stream and have these small queries insert to one big table. And now defining it is just a matter of describing what is a completed order off of Shopify. It's really quick and it's simple. And now the barrier to answer a question no longer needs to go through data engineering. No longer do you need, if you have a nuanced question, to go through a data engineer to create a table. You can use a UI to actually assemble these complex questions in minutes. And this UI, because of the consistent structure and because of the data being so in the same exact format for every company, this becomes really easy. And because if you can ask any question in the way of customer, activity, and time, you can answer it using a tool. I hope that this whole talk is to show you a little bit of what the power of time series data and that there exists a world where all your different systems can be simplified into a single table, and that one table can be used to answer any question because that table takes the gap between the way you ask a question and the way you answer it and just makes that really go down to 0. If you have any questions, you can reach out to me, Ahmed at Narrator.ai, and I would love to talk to you and take your cases of, no, my business is more complicated than you think. Let's go through it, and we'll get on a whiteboard, and we'll see if it works for you. Because so far, there's been most companies we can make it work for, and it ends up making data simpler and a pleasure. And then you can end up not being miserable and loving answering data questions. Thank you.
Thank you. So I wasn't entirely clear. BI tools, do you like them or no?
No. I think like BI as a concept is very valuable to business. You want to communicate information, but they're so limiting. You're so used to like having a specific plot over time and saying, well, I want to ask a more nuanced question, and you're stuck. And what that ends up doing for a lot of my experience personally is people start looking at plots over time and creating associations in their heads and then making decisions when they're not asking those kind of questions. And the way we kind of like to think about the future of answering questions is through stories. And a story, you don't need that much fancy visualizations. Raytheon, we only use bar plots and line plots, and you could solve missile defense. I'm sure we can do that with business. So line plots, bar plots, and some text and some stories centered around a specific question, you can actually make a much bigger impact for the business.
Okay. So just one question from me, and then I'll open up to people. Can you help us frame this in the broader context of the evolution of ETL, where the E, where the T, and where the L happen, and where they maybe I mean, this is a pretty technical crowd, but if you want to define what it is and explain how it evolved.
Yeah. So ETL is extract, transform, load. And what companies used to do was take the data out of their raw systems, put them in a staging area, model their structure, and then load them into a place where all the data can be linked. You saw a transition about maybe 5 years ago to ELT, which was take all the data in its raw form, dump it in a warehouse, and then do the transformation on the warehouse layer. And I think EL, just getting all your data in a warehouse, is a relatively solved problem. There's so many companies that do that. Transformation is interesting because it's unopinionated. It's open-ended to the person who's designing the table to predict all the questions you want to ask and put the columns that you need, and then put that in a plotter so you can filter it. And then they need to maintain that. In the future world, it becomes like EL, then you define. You just define what your business is in terms of data as these activities. And then whenever someone has a question, they're not looking for a table. They're assembling that question using it like a tool like Narrator to assemble a table that they need to answer that question. So it kind of shifts where T becomes less, where you spend most of your time right now in T, becomes such a simpler like one-time cost thing, where you do it once to represent your business, and then you open that up to everyone. So that analytics is not going through dashboards and limitations, but it's open to anyone to ask questions and answer.
It goes from ELT to ELD.
Yeah.
I'm so
DA.
tweeting this right now.
ELDA. It's like EL, and then you spend like a couple of weeks defining your concepts, and then everything else is just assembly, so that anyone can actually answer that question, and it's limitless. It's not like you're not blocked by someone having to assemble it for you.
Great. Thank you. All right. Do we have questions? This one over there. We're about to throw the mic in a pre-Super Bowl warm-up.
Gotcha. Hey, thank you for the presentation, by the way. I feel like I'm not alone anymore. One question for kind of combining hundreds potentially of tables into one. Are there any major issues with, say, loading it and reading it in HDFS? Do you have to be very clear about how you partition the table to avoid time constraints and memory constraints when you're accessing it in like a Hive query format?
Yeah, that's a great question. It's actually one of my favorites. There's actually an interesting thing that happened where warehouses are designed for this format. Like, I don't know if you guys know, but BigQuery was initially a single table. And like all these different warehouses are designed to be long columnar data, and they handle that really, really well for you. So having a simple, our tables are 15 columns, they're very specific, and they're partitioned on time, as you would guess, and activity. And taking that one table and self-joining it, you actually get significantly faster performance. We've taken queries that were taking like literally 40 hours in Looker, and we've dropped them down to like 10 minutes. Queries that cross billions of rows end up happening in like 7 to 8 seconds on a warehouse. Like, this is pretty intense performance improvements when you have a simpler structure and you just relate it. So I think you'll quickly see is this structure will be so much smaller than all your other tables. Like, assembling all your tables into one table, that table won't be the biggest table in your warehouse. It'll be like the 7th. And it'll be significantly faster. So you'll get a huge speed bump. And it also starts doing this really interesting thing where it makes warehouses kind of agnostic, where you'll quickly start seeing that the speed improvement on Redshift and versus Snowflake versus BigQuery becomes interchangeable. Because what they handle is for those edge cases where you have like a bunch of, like Snowflake is really good at a bunch of small tables everywhere trying to load in memory. But for long tables, you end up having the same performance, and it's a significant speed up than your normal approach.
Hi, great presentation. Quick question, not truly your competitors, but some of them, such as InfluxDB or Graphite or some of those time series databases, what are your points of differentiation?
Yeah, we're not a time series database. We live on the company's warehouse. Data actually never leaves the company's systems. We take data, we transform it in the warehouse and keep it in the warehouse. And we leverage the warehouse for their compute power. So more of our addition is our framework and our ability to use that one table in your warehouse in these infinite ways to answer questions. We actually don't structure the data or take it out of your system at all.
Great. Just one last one, if we can keep it reasonably quick.
Can you hear me?
Okay. Yeah, cool.
Quick question. So, the BI tools do visualizations. I mean, one of the reasons why you have BI tools is to visualize the data. So what do you folks offer in terms of visualizing the data?
So we have these things called narratives, and I think narratives they're designed to be stories. A story, a narrative is a question with a takeaway and some goals, and it's a collection of plots, bar plots or line plots only. And if you ever want to talk to me about why you shouldn't use anything else, have a conversation. Text and some slight widgets to simulate some data. So that's kind of how it's about really making the barrier to understanding a plot is much smaller when it's very consistent. And therefore, you don't need a pie chart for anything really. These are infographics, and we don't want to clutter the system with infographics to make things look really pretty. I think you can do that with specific tools when you need to make it pretty. But for answering questions and understanding and iterating, clarity is what we optimize for. So just plots are useful within a certain degree.
Very much,
Awesome.
I
Thank you so
appreciate
much.
it. Thank you.
Great.